All right, we have a empirical distribution problem. These are a little bit more intense, so let's take this carefully. So we have a taxi company operating in two regions, and we have a histogram showing the prices of rides in those regions in the last week. The first question we want to know is which data set can we use the empirical? And by the way, these are all correct answers, and we'll see how they get those. So empirical rule only works with normally distributed data, or approximately normal. You should be able to see the bell curve more or less. So in this region B, region B here, um, we are needing to get a brush. There we go. We see this kind of bell curve take place. That wasn't the best representation of the data, but you can kind of, if you squint your eyes, you can see most of the data in the middle and then kind of sloping out on the end. Whereas region A, this is clearly not a bell curve. We should not use empirical. What could we use with that, by the way? Chebyshev. Chebyshev works for any distribution, including normal distributions, but it's not quite as precise. So if you know it's a normal distribution or about that, you should probably use empirical rule or z-score, something to go with the normal distribution. If it's clearly not normal or you don't know what it is, then you have to use something more like Chebyshev's or just general distribution things instead of using the empirical. So only use this with bell-shaped data. For the data set identified in part A, notice we're talking about this data set, not region A. It's the data set identified in part A. Use the empirical rule to make the following approximations. The percentage of rides costing between $5.42 and $35.48 is approximately, well, with empirical rule, we only have three choices. So we have 68%, that's plus or minus 1 standard deviation from the mean. Maybe I'll put that here, from the mean. Or it's going to be 95% of the data, which would be plus or minus 2 standard deviations from the mean. Or we're at 99.7%, which is plus or minus 3 standard deviations. And notice each standard deviation is $5.01 in this particular case. So if our mean is 2045, which by the way is about right there, something like that, and we wanted to go 1 standard deviation away, I'm going to draw it right here. And how do I know that that's 1 standard deviation? Well, I looked down here and it's $5.01. I can see, oh, these bars are $5 away. It doesn't have to match up with the bars. That's just coincidence because of the way they did this particular graph. But the way it will always work, you're adding and subtracting 1. So if we want to get 68% of the data, that would be between, well, we'd start at the mean, and then we'd subtract and add 1 standard deviation. So subtracting it, we'd go down to $15 and 44 cents. And adding 501 to this, we'd get $25.46. So we can say that roughly 68% of the taxi rides here would be between 1544 and 2546. Notice that doesn't match the two numbers we were given here. So let's find 95%. 95%, well, this is going to be plus or minus 2 of these standard deviations. In other words, plus or minus 2 times 501, or $10.02 below, which would be $10.43. And going up, we'd have $10.02 above, which would be $30.47. That also does not match up. Let's go ahead to the third. So the point is, you're going to capture almost all the data in a normal distribution when you go 3 standard deviations out in both directions. And this should give us $5.42 and $35.48. How am I getting these? I'm just taking 3 times my standard deviation. That's 3 standard deviations. And I'm subtracting and adding it from the mean. Okay, and that does match the two numbers we're looking at, which for empirical rule it always will. When you do general z-scores, you can get everything in between, but for empirical rule, it's got to line up on exactly one of those. And that's going to be 99.7% of the data. It's 3 standard deviations away. Approximately 95% of the rides. Well, here's where our extra little work here in part B make part C very easy. Approximately 95% of the rides cost between what two numbers? Well, we've already gotten that. So it's just those two numbers right there. It's not a bad idea just to go ahead and do all 3 of these calculations for the empirical rule. Just figure out 1 standard deviation below and above. That's 68%. 2 standard deviations below and above, that's 95%, and 3 standard deviations below and above, that's your 99.7%.